Hey there, welcome to dotnetFlix. We're going to talk about NATS.
NATS?
What's NATS, Edwin?
Yeah, let's dive in. I have a couple of slides to tell you what NATS is, and then I also have some demos to show you what it is.
Okay, sounds good.
I guess it was about a year ago that a colleague of ours was working on with NATS at a customer, and I'm always interested in service buses and message brokers and stuff like that. So I looked at the website and I really liked what I saw, because what NATS basically is, it is a high-performant and lightweight messaging infrastructure. And this is these are big words, and I will dive into a little bit why it is lightweight and high-performant. And it is really cool for building cloud-native distributed systems.
Alright.
So you can use it for all the messaging between the components in a distributed system, just as other brokers like, for instance, RabbitMQ or Azure Service Bus or stuff like that. And you can compare it to that if you look at the concept, but there are quite a few differences which I will highlight in this session.
And NATS is open source, right?
Yeah, it's completely open source. If you go to the Github repo that's up here, you can see all the source code, you can contribute, of course. There's also a company called Synadia, and the founder of NATS is the CEO of that company. They support it, and they also give you some enterprise level support if you want that. And it's also part of the Cloud Native Compute Foundation. So yeah, it's completely open source stuff. It is a mature product, so it's at version 2 right now, and it is really extremely battle tested because the initial version of NATS was created for Cloud Foundry. So the entire control plane of the Cloud Foundry cloud provider was built on top of NATS. So that's a pretty big workload.
Yeah.
So I will call that battle tested. There's basically a client library for all the modern programming languages out there, so you can use NATS from whichever platform you're programming on. And this is also because it is small, it has a very small and simple text-based protocol.
Okay.
It is just sending you strings over TCP, and this is why it's also fairly easy to build a client for it. So if you are on a platform that doesn't support it yet, you can build your own client. And this is basically the entire command stack that it supports.
Okay.
And I can show you that. This is also very nice to do. I have a terminal here, and what I could do now, I could, for instance, say I will do a telnet session, and I go to demo.nets.io, which is a server that's always up and running on the internet on port 4222, which is the standard port that NATS is running on. And if I do that, I'm now connected to the server, and now I can connect as a client. And because it's all text-based, I can say connect, which is one of the commands that I can send. I have to give it a name. So I'm Edwin, and then I'm connected. And I get back plus OK, which tells me that this was successful. And now I could, for instance, create a subscription on a subject, and we will get back to that in a little bit later what it is. But that is where you send and receive messages. So I could say subscribe, I give it the name dotnetFlix, and I give it ID 1. I just give it my own ID. And then it says, okay, so now I have a subscription. And now if I, from another client, send something to this subject, I will receive it. I will do it now within this session, so I can say publish to the dotnetFlix subject, and I want to send you 12 bytes, and I would say NATS rules. And then I get back an OK, so the bytes have been sent. And you see that as a client, because I have a subscription, I get a message and I get the payload. So it's that simple.
Nice, so it's really lightweight. And I guess that also makes it very suitable for edge devices.
Exactly, yeah. So it's really lightweight. It is also completely written in Go. If you download it, it's just one executable that you start up, and then you have a NAT server running. It just listens on a port. I can also unsubscribe. And the really cool thing that NATS offers is that it really protects itself. So if you as a client misbehave, and that could be you don't send anything that's within the protocol, or you're not fast enough, then the server will just disconnect you. So you are then the scapegoat, and no other client needs to
So you are not
be
fast enough in handling a message.
Handling the message. So if they send a message to you and you don't handle it fast enough, then you will be eventually, this is not the first time, but eventually you will be disconnected. And there's also a very elaborate heartbeat mechanism. I can show you here.
Wow.
You send a ping and you get back a pong. And if you wait long enough, I will also receive pings from the server, and I have to reply with pong to make sure that
you're alive.
Yeah, and then the server knows that I'm alive. And like I said, if I do anything that is not within the protocol, I will be disconnected immediately. So
Nice.
it's pretty cool. So what are the features that NATS gives you? Well, like I said, it is really designed for simplicity, performance, and availability. And it's not so much about a rich feature set. If you compare it, for instance, with a RabbitMQ, RabbitMQ has, the complete AMQP protocol.
Yeah.
NATS doesn't have that. RabbitMQ has dead lettering, automatic dead lettering. It has content-based routing. All that kind of stuff is not in NATS. You don't get that. So it's pretty simple. I only get at most once delivery guarantees. So there's no message persistence in the service. If you're not connected as a client, you won't get the messages at the time they are sent. Okay. So there's no queue, there's no persistence whatsoever. You only get publish-subscribe messaging semantics. So you send a message, multiple clients can connect and they all get a copy of the message and that's it. There's no other way of doing things. There are some more elaborate patterns that you can do, I will show later, but you need to do something different for that. But this is the basics that you get out of the box. Well, the subjects, we've already talked about it. A subject is basically an endpoint where you can send messages. It is a named endpoint. And this is what it looks like in a picture. So I have two subjects here running in NATS, temperature and humidity. And if I, as a producer, send a message to temperature, only consumer A and consumer B will receive a copy of this message because they are subscribed to that subject.
Yeah.
And consumer C is described to subscribed to a different subject.
And so this is a scenario where you can afford to lose some messages, right?
Exactly.
Because you're probably only interested in the latest temperature and the latest humidity reading.
Yeah.
But you really have to think about that, because if you cannot afford to lose any messages, NATS may not be for you, at least not in this setup.
Exactly, and these trade-offs you need to be able to you need to be aware of them. So it is pretty fast. I have seen benchmark in which they send up to 8 million messages a second through NATS, which is pretty fast. So if you need raw performance, but then you have to be careful that if you lose a message, that mustn't break your scenario.
Yeah.
So, well, like I said, a subject is just a string. You can only use alphanumeric characters and the dot character. And the dot character is a bit special because what you can do with the dot character is that you can build kind of subject hierarchies.
Okay.
That is why the first time that I read about it, it said subject-based message routing. And I thought, well, it's not really routing, right? I send it to a subject and then you can connect it. That's it. But by doing this, you can, like this, for instance, if you have an international store and you have a couple of stores in the US and a couple of stores in the EU, like this you can build a hierarchy, and then by sending messages to these individual subjects you can route messages to different receivers. So it is very basic, but this way you can build a pretty elaborate hierarchy. Let me show you some code how you can use this from .NET Core, for instance. I'm using the .NET Core client. So let's go to Visual Studio Code. I have a very simple demo here. I have a producer, and this producer will connect to the NATS server running on my machine. And for that to happen, I of course have to run a NATS server. So that's what I'm going to do first. Like I said, it is just if you download the code, or if you download the NATS server, you just get an executable. This is on Windows, but also on Linux. You get an executable and you can start it. So if I say, for instance, start the NATS server, it will start up, it will start listening on localhost 4222, and now the server's ready. That's all there is to it. There's also a Docker container, of course, that you can run, and you could also run it as a Windows service if you want on Windows, but this is a very easy way to do it for a demo. And then what you can do, and this is the way it works in the .NET client, you have a connection factory. There are some options that you can use. In this case, I am telling it the URL. Where it needs to connect, in this case localhost 4222, but there are a couple of options, and I won't go into all these options here, they're all documented on the site. And then you create a connection, and in this case this is in the demo application, so I'm storing this connection somewhere as a global variable, and I reuse that for all the different demos, but this is how you connect to the server. And then, for instance, what you can do is just plain pub sub. And this is a very simple demo, of course. I will loop, so I'll send multiple messages. First I create my payload, which in this case is just a string, but it could just as well be some JSON that you serialized, whatever.
Or even some binary data, I guess?
Well, yeah, basically what you always send is a byte array. So for the .NET client, you always have to send a byte array, and what you put in it, it's up to you. It is opaque for the server.
So I could put in a JPEG picture.
Yes, if you want, no problem. And that's also because you don't have any content-based rounding whatsoever. The message is just transported, and there's nothing being done with it on the server side. So, like I said, in this case, I'm just doing a UTF-8 get bytes. So I get the bytes for this string message, and then I call the publish method. And this is the .NET Client SDK. I publish it, I give it the subject that I want to send it to, in this case, nets.demo.popsup, and I give it the data. It's as simple as that. And this will push the message to the server. And in this case, I do a thread sleep and then do that a couple of times. Like I said, there's no message persistence. So if I want to get these messages, I also should have a consumer up and running.
Right.
So I'll start these in a minute. And if you go to the consumer, it's the same thing. I connect to the same net server. The same thing, it's a connection factory, and then I subscribe to a PubSub.
So if your listener isn't running and you are starting to write messages, and nobody is subscribed to those messages,
they will be discarded at the server.
Silently, or
Silently.
do you get some notification?
There's no acknowledgement, just send the messages, fire and forget.
Okay.
Yeah. This is also one of these trade-offs that you need to be aware of. There's no acknowledgements whatsoever. You can build them yourself, we will get back to that a little bit later. But standard, it's just send the message and that's it. This is a way to subscribe to a subject. So in this case, I use a synchronous subscription. There's also an async variant I will show you in a minute. So I will say, on the connection, create a subscription on nets.demo.popsup. So here I specify the subject I want to listen to. And then I loop, so this is a polling mechanism. I say, give me from the subscription the next message. If I have a message, then I will dump it onto the console. Or handle the message, but in this case it's just a demo application. So let's start it up. So I have a nice script that will start the producer and the clients at the same time. There it is. So it will start the producer. I will put it in here. And I have a consumer. And I have another consumer, which is in here. Because I want to show you with multiple consumers.
Okay, right.
Right?
So those are just two instances of the same code you...
Yeah, it's two of the same .NET processes running here. So what I can do now is I can show you PubSub, the code that we just looked at. And now you see that when I send the message, both of the clients will receive this message. Pretty simple stuff.
Makes sense.
Yeah. Then there's another thing, which is load balancing, which is pretty awesome. I will close this one. Because what it supports is queue groups. And in this case, I am creating a subscription. And in this case, it's an asynchronous subscription. We just saw a synchronous version. And with the asynchronous subscription, you first create an event handler, or you pass in a lambda, that's also possible. Yeah. But you create the event handler of type message handler event args. This is from the client library. And then you get the arguments, and in these arguments you can get all the data and also some metadata of the message. So the subject it was sent to, and there's some other metadata in there. But you could get the data. I know there's a UTF-8 encoded byte array in there, so I will just decode it, get the data, and then send it to the console. And then if I have this event handler, I create an asynchronous subscription. I create it on this subject.
Right.
And what I can then do is I can pass in load balancing, or a queue group, as it's called in NATS. And what this basically does is if multiple consumers connect to the same subject with the same queue group, then the server will automatically randomly divide the messages over these two consumers.
Nice. So it's basically a competing consumer
It's a competing consumer pattern, and it load balances. And it's completely random, so you have no clue. It's just not 50-50 or something like that. It's completely random.
Okay.
So, well, when I started the consumer, it already registered its subscriber. So if I go back to the demo, sorry, where is it? I was struggling with these windows. There it is. And if I now do load balancing, I sent the same set of messages, and now you can see that they're randomly divided between these two.
And you didn't change anything in the listener, right? It's all just server side.
It's all server side. Yeah. I sent the messages. Yeah, I did. Well, of course, I did subscribe to this subject with the queue group on the consumer side. So the sender doesn't know
Yeah,
anything.
okay. You need to subscribe to the Q group,
Exactly,
otherwise
yeah.
you won't be part of the competing consumers. Yeah.
But for the producer, it's completely transparent. You just send messages and then it's load balanced by the NATS server. So, which is pretty cool. And then we get to some more elaborate patterns, because I said that you have pure pub sub. But the really cool thing is that you can also subscribe for a request response.
Okay.
And I will show you how this works at the producer side in a minute, but this is how it works on the consumer side. So again, I create an event handler, I get the data and show it on the console, and then, like I said, there's some metadata in these arguments. There is a reply subject in the message.
Okay.
So as a producer, I can say, send this message to NATS, and if there's a consumer listening, then pass in this subject that the reply can be sent to.
Yeah.
Which is pretty cool. And then, if there is a reply subject, I will just create a response message, I will create a response message and just publish that to the reply subject. So I, as a consumer, just send the response back to another subject with
some reply to address. And is
Exactly.
there also some kind of correlation token here, so that's the original sender can correlate it back to?
You can do that, but then you have to put it in the payload.
Okay.
So in this case, it is just the unique subject.
Yeah.
And the really cool thing is if I go back to the producer, this is the consumer, let's keep them open. If I go to the request response, so just to go back to this queue group, there's nothing different here.
Yeah.
What we just saw.
Yeah.
I will just send it and
Just
the queue group
publish to the queue group.
is consumer side. And then there's two ways to do this request response. And this is the hard way. And this tells you exactly how this is done on the producer side.
Okay.
So first of all, and this is basically my correlation token, what you just talked about, I will create a string underscore inbox dot and then some GUID, some unique thing.
Ah, so you create a unique subject.
You create a
for each
unique
reply.
subject, yes.
So is there some
We'll get
some
there.
cost
Yeah, there is some
associated
cost.
with creating a subject?
Yeah, it is, but it is negligible.
Okay.
So it's very, very small. So we create the subject, and then we create a subscription, a synchronous subscription in this case, on this subject. And then there's a really cool feature of NATS. You can say, auto unsubscribe from this subject after receiving one message.
Ah.
Because I'm only interested
Yeah.
in one response. This is really basic request response.
And then does it also clean up that subject?
It automatically throws away the subject.
Okay.
And even if you have multiple consumers that will send back messages after the first one came in, they will silently be discarded by the server. You don't have to do anything
Because
for
the
that.
subject doesn't exist anymore.
Exactly, because the subject is gone. And this way, if you take it a little step further, so if I have multiple consumers, I could create a scatter-gather pattern.
Yeah.
So I send something to a load out, a scaled out set of search services or whatever, and the first one that responds, I will take that response and the rest
Yeah,
is
and
just
ignore the
discarded.
rest. Nice.
So this is pretty cool.
Yeah.
Okay, there is a convenience method in the .NET client. Most of the clients have this. So
Okay.
I could also say, create me a new inbox, and then it will create a unique inbox for me.
Right.
And then I just send the message, and then when publishing the message, I will specify the reply subject. And then I wait for the next message to come in within 5 seconds. I can specify a time right here on this single subscription. And once this the message comes in, then I will handle the data and I don't have to do anything. Everything is cleaned up on the server side.
Nice.
Which is pretty cool. Yeah, I can show you that. I will send the messages and I will get a response back. That's not really, really special. But what is special is that this entire pattern is implemented in the .NET client using the request method.
Oh.
So if I do this, then under the hood, automatically an inbox is created, an auto subscribe one is done on this subject, and I will just get a synchronous request. And if this call returns, I will get the data back as a return.
Nice.
And then I can just do something with the response. So this is pretty convenient.
Yeah.
Yeah, also some wildcards in here. I won't go into that a little bit more, but this is to show you how you can work with this net server from .NET, which is pretty cool. And yeah, I think it's very, very efficient way of sending messages. And if you have, like we said, you don't have the requirement that every message must come to the server, then this is pretty awesome. And
Yes.
it's pretty
So I guess especially in IoT-like scenarios,
Exactly,
this is really useful.
Yeah.
So the client you're using is a .NET standards
Yeah,
package?
this is .NET Standard. So this is all .NET Core, what I'm running here. Yeah. And of course, I'm just scratching the surface now of this client because there's all kind of events that you can set a handler on if you become disconnected or stuff like that. So it's a pretty elaborate client, but the basics of sending messages is really easy.
It's all around those simple primitives.
Yeah,
that you
real
can use.
simple. And that's basically everything that you get out of the box.
Yeah, nice.
Yeah.
So if I want to play with this myself, do you have some code up at your...
Yeah,
Git repo?
all this code is up on the Git repo. I will put this in the show notes.
Okay,
Yeah.
awesome. So, hope you enjoyed this session. Have fun with the code, and
Yeah.
see you next time.
Yeah, and maybe next time we can look at clustering and also look at NATS streaming.
NATS streaming.
Yeah, because
That sounds interesting.
That's an addition to NATS, which will give you some additional features.
Okay. So
let's-
we'll have a look at those advanced
Yeah.
features in the
Awesome.
next episode.
Thanks
See
for
ya.
watching.
Bye-bye.
Bye.